Hi everyone, meet you again in week 2 for chapter 2. For this week, we will share with you all about design for usability. What is usability? Have you ever heard about this term? Well, it comes from the word use, usable, something that people can use. So, actually, what is usability? Usability is how do we achieve a good design? So, there must have a clear goals, right? About what and how we want to achieve a good design. So, the goals of usability are: first, effective to use. People should effectively use or apply the interface or system that we build, and also the interface or technology make the people life easier. Second, efficient to use. From the design people is more efficient in their daily routine and work. Third, satisfaction. Of course, right?
So, in order to achieve all the goals of usability, there are many principles that we can follow. One of it is 4 principles of user-centered design. They are: first, early and continual focus on users. Second, integrated design. Third, early and continual user testing. Fourth, iterative design. As a conclusion, users don't have great user interfaces. They hate poorly designed ones. Cheers! Bye-bye!
Every day, we use our eyes to understand the world around us. It's so natural and effortless that we don't really think about it. Unfortunately, our devices today lack the ability to sense our attention. Eye tracking will change this. It will enable you to interact with devices in ways you only dreamed was possible. Our vision is to transition eye tracking from being an expensive lab equipment into everyday products. Soon, this technology will be integrated into a wide range of devices, such as tablets and smartphones. Today, you can get started with the iTrack Tracker. This device can tell where someone is looking with a precision about the size of a fingertip. Devices will behave more intuitively. Games will become more immersive. It's the world's first affordable eye tracking device that contains some of the very latest technology. Bundled with the device comes our software development kit. With just a few lines of code, your apps will start to receive a real-time stream of eye coordinates.
Week 2. Design for usability. Why usability is important. On the web, usability is a necessary condition for survival. If a website is difficult to use, people leave. If the homepage fails to clearly state what a company offers and what users can do on a site, people leave. If users get lost on a website, they leave. If a website's information is hard to read or doesn't answer users' key questions, they leave. Note a pattern here. There's no such thing as a user reading a website manual or otherwise spending much time trying to figure out an interface. There are plenty of other websites available. Leaving is the first line of defense when users encounter a difficulty. The first law of e-commerce is that if users cannot find the product, they cannot buy it either. For intranets, usability is a matter of employee productivity. Time users waste being lost on your intranet or pondering difficult instructions is money you waste by paying them to be at work without getting work done. Current best practices call for spending about 10% of a design project's budget on usability. On average, this will more than double a website's desired quality metrics and slightly less than double an intranet's quality metrics. For software and physical products, the improvements are typically smaller, but still substantial. When you emphasize usability in the design process. For internal design projects, think of doubling usability as cutting training budgets in half and doubling the number of transactions employees perform per hour. For external designs, think of doubling sales, doubling the number of registered users or customer leads, or doubling whatever other KPI, key performance indicator, motivated your design project. Additional notes. The process of design. Steps in design. Requirements. What is there and what is wanted? Analysis. Ordering and understanding. Design. What to do and how to decide. Iteration and prototyping. Getting it right. And finding what is really needed. Implementation and deployment. Making it and getting it out there. I do it all. Limited time, design trade-off. Usability. Finding problems and fixing them. Deciding what to fix. A perfect system is badly designed. Too good. Too much effort in design. Who are they? Probably not like you. Talk to them. Watch them. Use your imagination. Application design. Local structure. Single screen. Global structure. Whole site. Rules. knowing where you are, knowing what you can do, knowing where you are going or what will happen, knowing where you've been or what you've done. Design and layout. Basic principles: grouping, structure, order, alignment, use of white space. Basic principles. Ask: what is the user doing? Think: what information, comparisons, order. Design: form follows function. Use boxes to group logical items. Use fonts for emphasis, headings, but not too many. Grouping of items. Defrost settings. Type of food. Time to cook. And control. Entering information. Knowing what to do. Affordances. Forms, dialog boxes. Presentation plus data input. Similar layout issues. Alignment, NB different label lengths. Logical layout. Use task analysis. Groupings. Natural order for entering information. Top, bottom, left, right, depending on culture. Set tab order for keyboard entry. To do. What is active, what is passive? Where do you click? Where do you type? Consistent style helps. Web underlined links. Labels and icons. Standards for common actions. Language, bold. Current state or action. Psychological term. For physical objects. Shape and size suggest actions. Pick up, twist, throw. Also cultural, buttons afford pushing. For screen objects. Button-like object affords mouse click. Physical-like objects suggest use. Culture of computer use. Icons afford clicking. Or even double-clicking. Not like real buttons. Appropriate appearance. Presenting information. Aesthetics and utility. Color and 3D. Localization and internationalization. Purpose matters. Sort order. Which column? Numeric alphabetic. Text versus diagram. Scattergraph versus histogram. Use paper presentation principles, but add interactivity. Softens design choices. Reordering columns. Dancing histograms. Color and 3D. Both often used very badly. Color. Older monitors limited palette. Color overused because it is there. Beware colorblind. Use sparingly to reinforce other information. 3D effects. Good for physical information and some graphs. But if overused, text in perspective. 3D pie charts. Across countries and cultures. Localization and internationalization. Changing interfaces for particular cultures or languages. Globalization. Try to choose symbols, etc. that work everywhere. Simply change language. Use resource database instead of literal text. But changes sizes, left, right order, etc. Deeper issues. Cultural assumptions and values. Meanings of symbols. Tick and cross. Positive and negative in some cultures but mean the same thing. Mark this in others. Prototyping. You never get it right first time. If at first you don't succeed. Self-assessment, 3 minutes. Question 1. Computers can be hard to use. Even today, the use of an unfamiliar system can be a hit-and-miss process. The more functions there are in the system, the bigger the problem. Yet many of us are reluctant to admit to difficulties in using information and communication technology, ICT. Discuss why this is true and explain what kinds of challenges the designers of modern computer systems must deal with. Review questions. Self-assessment. 3 minutes. Question 2. What makes something easy to use? What are the properties of an interactive system that make it easy to use? For example, your list might include: are the instructions clear? Is the machine efficient? Answers. Question 1. One view is that ICT is the home of the expert. On this view, to admit to a problem with ICT is to admit to an apparent lack of expertise. Yet computers are often found to be difficult to use. Why? It's possible that all the users who complain of ICT problems simply lack the necessary skills. But that seems unlikely. It is also typical for system vendors to assume that their customers are at fault. There may, however, be other explanations than simply blaming the users. Problems may be due to poor design or training. That is where we can think of HCI and user-centered design. If we design interactive systems, but ignore the needs and preferences of the user, then we risk creating difficult-to-use products. Using a new computer package or a novel phone system is often like finding your way through a maze. Despite errors of omission and commission, you find your way through in the end. You memorize the sequence of instructions and ignore anything you don't need. Answer for question 1. The designers of modern computer systems face a number of significant challenges, including great variation in use. PCs are expected to support a wide range of tasks. A range of different contexts, ranging from the office to the battlefield. Significantly different users, abilities, training, disabilities and objectives, and the difficulty of explaining how to use it to a diverse and often unknown audience. A large number of different features and functions, often buried underneath layers of menus. Answer for question 1. These challenges underline the importance of putting the user at the center of the design process. Vendors of PCs, phones and other appliances are committed to supporting a wide range of tasks in as many contexts as possible for a diverse and expanding range of users. Vendors appear to believe that the best way to attract and retain users is to offer more and more features. Ironically, this surplus of features can cause real problems for the user. Many technological purchases are difficult to use until a lucky guess, or an accidental key depression, supplies some missing information. Review questions. Self-assessment, 3 minutes. Question 3. Investigate and try to solve the problem with principle of human-computer interaction. How to apply relevant principles appropriately to particular situations. How to design to match human perception, attention, memory and thinking processes. How to carry out a task analysis. How to describe an interaction in the form of design and evaluation. How to choose appropriate evaluation methods and analysis. Relevant interaction issues in some specific areas, agents, websites, ubiquitous computing.